In this third tutorial, we're gonna cover the entity component system. So we'll see how to manage objects, how they interact together, and we'll take a look how to create our first Visual Studio script to manage the object's behavior.
Hey, if you want to support this channel, don't forget to click on the subscribe button below. It's super important for us. Thank you so much.
The entity component system is a software architectural pattern that divides identity from data and behavior. So for example, here we have three entities, entity 1, 2, 3, and we have several components, a list of components on the left side. Now each entity can have one or more components, and these components contain data. Now the systems basically will take care of analyzing all of the entities and their components and performing the behavior according to the data. Okay, back to Unity. If we take a look at where we left last time, so here we have our hierarchy view, which is where all the objects in the scene are listed. So if we select, for example, our main camera object, we see that it's being selected in the scene view. But if we take a look on the right side, where the inspector is, we see there are several components. Now, the first one is the transform component. The transform component is the basic component that all game objects in Unity must have in order to be able to be placed in the scene. Because the transform component contains information like the position, rotation, and scale of an object. So, very simply saying, if we take a look at our main camera and navigate closer into the scene, we see that we have the three axes, X, Y, Z, and we can move the object, for example, on the Y, on the Z, on the X, and the motion that we perform is also changed in terms of data, so positional data, in our transform component on the right side. So we see that position is 0.9, 1.6, and negative 9.2. We can also hard set the data here by typing the values, and that will change the position of the object. So now our camera is right here in 111, okay? And so you see that there is a mirroring of the information that we input either here on the component itself, or we can manipulate the object by using the scene view on the left. Now let me place my camera back to 0, 0, 0, which is the center of the scene. And let's take a look at another component, which is the camera component. Okay, this is another component on top of the transform component, which of course defines the camera as an object, as an entity. Now, we don't go into the details of what the camera component is right now, but of course, all you have to know is that this component allows this entity, this game object, to actually be a camera, so being able to render the scene. Now, let's forget about the main camera and select our directional light object, which is another entity. Now, as another entity, it has other components. For example, it has another transform component. You see that main directional light is right here, so position Y3, and it has another component which is the light component. This specific component is what allows this entity to be considered a light, because it gives the information, the required information, to be considered a light. So it's clear that any entity without components is just a pure entity. But as soon as we add components, we add data, and of course, we can add behavior. But so, what are systems? Systems provide the global scope for entities and components. So they operate on the components. For example, let's assume that we have a list of entities. In this case, we just have two, but we can have way more than that. And let's assume that these entities are moving because we are, let's say, changing the transform component via script. And so all of these entities, so all of the ones that have a transform component attached, they will be taken into account by the system that manages all the transform components. And one by one, consider all the objects as in the list, starting from the first one going to the last one, the system will operate on the transform components and will move these objects. Okay, this was the theory. Now, to make everything more clear, we'll see how it works with a real example. So we're gonna add another game object, so another entity, in the scene. We can do that in two ways. We can go here in game object, create. We can create several type of objects, for example, a 3D object or an empty object, which is just an empty entity. Or we can go here in the hierarchy and right-click 3D object, and we can choose the object, the specific object, or create empty. Now let's create a 3D object, which is a cube. So click on cube, And this is our cube. Now you see that the cube comes with the list of components, which are the transform component, and then other few components, for example the mesh filter, the mesh renderer, and the box collider. Now let's ignore these other components for now. Let's just focus on the transform component. It comes with random values for the position, so we need to fix that. Let's type something like 0, 0, 0. So now if we press F, we see that the cube is centered very close to the main camera, because the main camera is at 0, 1, 0, okay? So it's right on top of the cube. So let's move this camera backward slightly, and we'll see that what the camera is currently rendering is our cube, and we can move the camera down a little, and we see that the cube is being rendered in the game view below. Now let me give some good values to this camera so we can see the cube better. So main camera goes to x0, y0, and z, let's say -5. So my camera is right here. My cube is right here at 0, 0, 0, so right in front. Okay, so you see that in the game view my camera is rendering the cube perfectly. Okay, what we do now, we're going to create another folder in our project browser. So here we select our assets, we right click and create another folder which we call scripts. In this folder will contain all the scripts for this game. So what is a script? The script is the piece of code, and you can consider the script as a component in this scenario, which will allow us to define a specific behavior on the entity which we're going to place the script on. Okay, it's time to create our first C# script. So let's select our scripts folder, right click in the blank area here, create C# script. You want to give it a name, so let's call it cube script. Press enter. Okay, so every time you add a new script, the solution will recompile, and in order to open the script, you just double click on that. This should launch Microsoft Visual Studio. Okay, so this is what a C# script looks like. Let me zoom in a little bit. The purpose of this tutorial today is not to introduce C# as a programming language. It is just to show you a real scenario where we apply the entity component system pattern. And so I'm not going to go into the details of what this is, okay? Not today at least. So what I'm going to show you is that if we save this script, so save, let's minimize and go back to our editor. Okay, this script can be treated as a component. So if we go in our cube and select that, you can take your script, drag and drop it in our inspector, and you see that it's being added as a new component for this entity. Now this script will contain code that will define behavior. So you see that we're closing the loop. So we have an entity, which is the cube, we have a component, which is our cube script, and we have a system that will operate on all of the scripts, like this one here, that will perform some operation on the cube object. For example, let's assume I want to move my cube. What I'm gonna do, I'm gonna go in the update function and type transform dot translate, and we can say the direction, so vector3 dot up times time dot delta time times, let's say 5f as a speed. So this little code is going to translate my cube, so the transform of the object on which this script as a component is attached to, and will operate a translation given this axis. So vector3 up is the axis that is pointing up, so the y-axis, and this is just some other information about the speed. We're not going to go into the details of what delta time is today. So let's see how that works. We can save it, go back to Unity, solution will recompile, and if we now press play, the system that is responsible for operating on the script will take into account the fact that a script is attached as a component to the cube entity and will operate the behavior. So if we press play, you see that my cube is flying up at the given constant speed. Consider that every time we have a script, we can access all of the components. This is just an example to show you how a script can perform an operation on an object. But of course, as you might imagine, as an example, this camera has a camera component which we can access via a script, and we can perform other operations. For example, we could change the field of view at runtime dynamically, just like we moved our cube.
Thank you for watching this video, I hope you enjoyed it. Don't forget to like and subscribe, and see you at the next one.